All right, my friends, so we are going to wrap up Unit 4 today with our final lesson. All right, this is on page 163 in your workbook. All right, and you can see that we're going to continue what we've been doing for the last couple lessons, I should say, which is using our knowledge of angles formed by parallel lines and transversals to set up relationships and solve. And today's focus will be, all right, on solving things that result in a quadratic relationship. This opener is very similar to what we did before, all right, in a prior lesson. So we're just going to kind of skip this, all right, and come down to the notes, just as a reminder. All right, so quadratic equations usually have two solutions, all right, and then we talked about this, that angles, right, all right, must be between 0 and 180 degrees, correct? So we want to always keep that in mind, right, because one or both of those solutions, all right, may not do that. So we will always want to go back and check. And then the last thing that we always want to remember when we're working with quadratics, right, is that we have to get it equal to 0. All right, ax squared plus bx plus c is equal to 0. And then remember, we have several, all right, ways to solve. And once again, we are not necessarily grading you on the method that you use to solve, but you have to be able to solve, all right, a quadratic equation. And it's just good if you're really good at all three of those, because there are certain situations where they're more advantageous than others. All right, well, let's go ahead and get into the work, all right, on the lesson. So let's flip, and let's look at example 1 on page 164 here. So once again, the idea is we want to identify the types of angles we have, all right, then from that, we want to then write down the relationship that exists between those types of angles. So when I look at problem 1 here, I can see that I have these two angles, all right, and we know that these are alternate interior angles. And then what we know is now we intersect two parallel lines. So we know that alternate interior angles, all right, touching, all right, our parallel lines are equal to each other, right? So we know the measure of angle 1 is equal to the measure of angle 2. All right, so I can take 2x squared minus 4, and I can set that equal to negative 16x, all right, and I think that is, yes, that's a plus 14 there. All right, okay, so now there's our types of angles were alternate interior. The relationship is that they are equal because our transversal intersects two parallel lines. Now we have a quadratic equation, all right? And now we have to get it equal to 0. So I'm going to add 16x to both sides. And notice there's not an x over here, so I'm just going to kind of put that in the middle. And I'm going to subtract 14 from both sides. So I end up with 2x squared plus 16x minus 18 is equal to 0. All right, now, a couple things when we're solving. So one is a GCF, right? So sometimes we can see a GCF, and we can use that GCF and pull it out of the problem, and it makes our numbers a little bit easier to work with. So for example, in this particular problem, all right, we can see that 2, 16, and 18 are all divisible by 2. Now, since we're solving, we can divide everything by that constant GCF, all right? So I can divide everything by 2, and that's okay. All right, so I get x squared plus 8x minus 9 is equal to 0. All right, and so if you have that common factor, all right, to all of your terms, you can divide by that number. And notice now that makes this a much different looking quadratic, and then it might be much simpler and quicker to factor. So if we go to our area model for factoring, all right, our a term goes here, our c term goes here, and we're always multiplying a times c, so 1 times negative 9 is negative 9. And then we're always adding to get our b term, which in this case is a positive 8x. All right, so notice now, this is a much simpler problem, right? Because there's only two factors, or pairs of factors for 9, right? It's either 1 times 9 or 3 times 3. And so when I look at multiplying to get negative 9 and adding to get positive 8, that would be 9 times negative 1. And then 9x plus negative 1x is 8x. So there are the two terms I want to drop into our area model here. And now we can go through looking for our GCF in each row and column. So if I look at my first column here, my GCF is an x. And when I look at my second column, my GCF here is a positive 9. When I go to my first row, my GCF here is an x. And now notice here, both of these are negative, and the only GCF I can take out is 1, so this would be a minus 1 right here. So there are my factors. So it would be x plus 9 times x minus 1 is equal to 0. And then I can take each of those factors and set it equal to 0 to solve for my x values. So I get x equals negative 9, and I get x equals positive 1. All right, so now notice, all right, here's where we have to go back and plug these in to see if one or both of them work. Maybe both of them doesn't work. It could be possible that we have a no solution type of problem. All right, so if we go back to this relationship here, right, this will allow us to do two things. It'll see if these angles are actually equal to each other, but it'll also allow us to see that our individual angle measures are between 0 and 180. So I'm going to take negative 9 and plug it in first. So 2 times negative 9 squared minus 4 equals negative 16 times negative 9 plus 14. All right, and then I'm just going to use my calculator here. All right. And this is what's nice about getting a calculator with a view screen, that gives me 158 on the left side equals, and then we can see if we get the same thing on the right side. And I get 158 on the right side as well. So I get 158 equals 158. So the two angles are in fact equal. They both have a positive measure between 0 and 180, so that's good. So x equals negative 9, all right, works. All right, and a common mistake by a lot of students is that they see that that result is negative and they immediately throw it out. Okay, and so it's not about what this value is. It's about what the result is once we go back and plug it in. Now, I want to do the same thing with 1 here. All right, so I want to plug in 1 here. So 2 times 1 squared minus 4 equals negative 16 times 1 plus 4. Now, when I do this, however, I'm going to get negative 2 equals negative 2. Now, that is a true statement. So the relationship is true, but it doesn't make sense within the context of what we're dealing with, right? Because we're dealing with angles. And we know angles need to have a positive measure between 0, all right, and 180. So this, in fact, does not work. So notice the positive number actually doesn't give us a solution that works, all right? So there you go, my friends. All right, and I think that is it for this particular video. All right, so go ahead and finish problems 2, 3, and 4. All right, check your answers with answer key. All right, and then I will see you in our next unit.